Hello, I'm back again with proof 8. Not back again, but this is the first time I'm doing proof 8 about Lebesgue integrals. And we're going to go about proving. Yeah, maybe I should write down proof 8. 8, which is the Lebesgue integral of e to the minus x dx. Alright. First, we're gonna write down. Uh, First, we're gonna write down the e to the minus x as a series of functions. So, and then sum them up essentially, which is how Lebesgue integrals work. So 0 to infinity, k to the 0, k t, where f k t, this is e to the minus t, k t, k plus 1, 0 otherwise. Alright, so let's first test for Lebesgue integrability, which is we got to calculate pi k, which is 0 to infinity, f of k t dt k plus 1 e to the so this is the way I kind of think about it is that it's sort of like a version of an inductive thing. It's not at all, but in my head I've sort of formed this as an opinion, which is like how I remember what to do. Okay, so the question is, does this sum, if I sum it over k, does it converge? Now each of the ik values is actually less than or equal to e to the minus k, which essentially means that the area of ft is less than the area of a rectangle. So we can then use the comparison test to sort of determine that infinity k equals 0, e to the minus k infinity 0, 1 by e k, and this in fact converges. Because as you sort of raise k, this gets tinier and tinier. So that means the Lebesgue integral indeed does exist. So now we gotta calculate the stuff. So I'm gonna start on a new page and calculate everything out. So 0 to infinity. Started off with f of t dt, which is equal to sum infinity k equals 0, 0 to infinity ft dt, which is equal to infinity k equals 0, k plus 1 e to the minus d dt, is equal to thing summation, so k equals 0, fe minus d, k k plus 1, which is equal to, writing the same thing, so minus k minus e to the minus k plus 1 infinity k equals 0, 1 minus e minus 1 e to the k, which is equal to 1 minus e 1 summed over infinity k equals 0, 1 by e to k. Just gotta solve all of these bits out, which gives us 1 minus e to the minus 1, and this thing resolves out to be 1 by 1 minus 1 by e. These these two terms cancel out to give you 1, and that is the proof by Lebesgue integral for e integral of e to the minus x, or rather the unbound integral of e to the minus x.